Okay, so thanks everybody for joining us the whole time. So right now we are going to start session 3, the last session for the first day. This session 3, the topic is about uh, multilingual NLP and low resource language processing. Um, the papers in this topic, under this topic, are quite insightful, interesting, some of the results that they have and approaches. So the first paper is Hate Lost in Translation, Evaluation of Multilingual LGBTQAI plus Hate Speech Detection. And Duke is going to present us. Thanks. Oh, sorry, the summation is a short paper. Thanks, Duke.
Hello. Hi, so I'm Duke. I'm a new PhD student at the University of New South Wales. My research area is NLP for English dialects. I'll be presenting 2 papers today, so I hope you'll bear with me and making sure that I have everything in my head. So this research, this paper is titled, Is Hate Lost in Translation? Evaluation of multilingual LGBTQIA plus hate speech detection. This research is part of PHI's 3-month Taste of Research program, and it's sponsored by Google's Exposia grant. Before I start, this presentation contains hateful and offensive language to the LGBTQIA plus community. So if you feel like you need to step out of the room anytime, please feel free to do so. Safety is a priority. Okay, so I guess the main idea is hate lost in translation. So as you know, most language models are transformer based. So it's encoder decoder model. It's translation based. So really asking about bias in language models. It's kind of related to thinking about, whether hate speech is preserved in translation, or is it just not preserved. So this is the analysis that we want to do, and we're going to evaluate it for 4 different languages, kind of English, Italian, Chinese, and code switch Tamil. Code switch Tamil means that it's Tamil, but not written in the Tamil script, but it's written in Latin script. And the task is hate speech detection. Yeah, so I'll just, so basically hate speech detection is important to ensure the safety of LGBTQI plus people online. And nowadays, most of hate speech detection is implemented via LLMs. And obviously we know that LLMs depend on large training data. When you have scarce training data, it doesn't really understand the vocab and stuff very well. And LGBTQIA plus is another area where the vocab is a bit niche and it's not that abundant in the training data. So we suspect that these statements with these niche vocabulary probably will be flagged as like hate speech. So this is what we want to investigate. And one of the ways that we will use to investigate it is via translation, so that it will reveal what kind of, what's underneath the LM. So existing work in this area, so there's been several shared tasks, as you can see. There's like generic, just generic homotransphobic tasks, but there's also like homotransphobic tasks for specific language speakers. For example, like homomex is like for Spanish speaker of Mexican origin, ALTA is for Italian. So most of the models that people have looked at so far is BERT-based or GPT-based. As far as we know, this is the first work to study LGBTQIA plus hate speech detection with the use of machine translation as anchor. So our pipeline is pretty straightforward. So we have like these different data sets, we pre-process them, and then we translate them via prompt. And then from those 2 data sets, we will perform our evaluation. We have 4 types of evaluation. First is just 0 shots. That's term original over there. Fine tune and then 0 shot. zero shot on the translated data set, which is term translated, and finally fine tune on the translated data set. So here are our 4 data sets that correspond to the 4 languages that I just discussed previously. So the data balance is pretty all right, except for English Tamil, which is like 90% to 10%. Everything else is like, it's a little bit imbalanced. So the model we'll be using is GPT 3.5 Turbo model. We'll be using the following metrics: F1 score, precision, recall, and Cohen's kappa. For F1 score, precision, and recall, we'll be using the weighted version because it's very imbalanced. Cohen's kappa is a measure to look at the rater's agreement with accounting for like agreeing by accident. And this is our quantitative analysis. So let's first look at the F1 score for just zero shot. So from here we can see, okay, I'll just like introduce the table first. So from the left to right, we have language, followed by the different setting, and then F1 score, precision, recall, Cohen kappa, and then we have delta F and delta K. Delta F refers to improvement or degradation between 2 specific pairs, and delta kappa is similar. You can find the whole thing in the legend, in the caption underneath, and I'll explain them as we go through them. So let's first look at the F1 score. So English is the highest with 79%, followed by Chinese 74%, for Italian with 59%, and English Tamil, which is 36%. So this is pretty interesting. The first observation we see is like, oh, English is number 1. That's pretty expected, but we also find it generalizes pretty well, this pipeline, to non-Latin scripts such as Chinese. And currently English Tamil code mix is the one that performs the worst. So obviously when we fine tune, so delta F, currently if you look at the red thing on the right hand side, so that's the performance difference compared to the zero shot original. So in all cases, it increases performance as expected, but the degree of improvement varies based on the language. So for example, for Italian improves by 23% compared to English and Chinese, which is only 6 to 7%. So now let's look at the translated. So when performing translation, we see that, so now the delta F refers to the difference between F1 of translated and F1 of original. And here we see that in most cases, it degrades the performance. There's only one instance where it sort of improves, which is like delta kappa for English Tamil, but the improvement is really, really slight. So it's safe to say that this is not a very effective way of translation is not an effective way of capturing hate speech. And if we fine tune on the translated version, so this is improvement upon translation on the delta F column, we can see that it improves. But if you compare between the fine tune original and the fine tune translated, you'll see that fine tune original always beats fine tune translated. So yeah, so that's about the quantitative analysis, and now we'll look at the qualitative analysis. For qualitative analysis, we'll be looking at translated zero shot, so that would correspond to the translated row for Italian, Chinese, and English Tamil. So here's the manual translation. Someone who have no shame wants to borrow other people's good reputation. So this is obviously offensive statement and labels true, but in the GPT translation, so the thing that it's missing out is highlighted in red, and you can see that it doesn't understand like the homosexual part, and so it's because of that, it's just translated as men and it leads to a false prediction. We have another one. This one is quite interesting. So this term, house husband, it's not really like a word yet in English, I think. So they don't know how to translate. It's just translated as woman. And again, it's like it misses the point. So now we're going to Tamil code mix. And here, So here, this is again a derogatory statement, and they use the word 9 to denote the transgender community. But again, like GPT completely misses it, and so it just generates gibberish. And here it mistakes like an adverb for like human name. This is interesting because so far we've only looked at cases where it's making some wrong understanding based on some LGBTQIA plus word, but here it's like it's just a normal word. Yeah, and this is the example from earlier where this is the Italian example, and they missed the derogatory word, which is in Northern Italian slang, and they miss it for just, they thought it's like a 2-word construction at the bottom there. This is another example. So this is like a very like common Italian slur, but it's like what is it? It's like involving saints and stuff, but it's not homotransphobic. So this is like, it's not biased towards LGBTQIA plus. It's just not understanding the regional language nuances. And this one is also interesting. So it's mixing up this derogatory word for like being rich because it just looks similar. So yeah, so far we can observe that the qualitative analysis shows that generally speaking, like paid speech detection works pretty well, but it seems like the 20% where it doesn't get it right, it doesn't fully like capture these small nuances. And so in terms of limitations of this work, number one, we use the same LM for both translation and classification, so which leads to biases because we're not isolating these two processes. The second thing is we didn't study the effect of prompt variation. In addition, we didn't examine the effect of translation quality because translation quality might have affected the quality of the classification. And we also use English prompts. So maybe that have affected things. And yeah, we could have used some other LMs. So yeah, in general, it's paid speech detection is generally effective, but it's good with non-Latin script. It's worse with code mix data, and yeah, and hate speech is not really retained through translation. So I think that's it.
Thanks, Duke. Okay, questions? Yes, so we will start from over there. Okay. Bye.
All right. Thank you for the talk. It's well set up experiment, a bit distressing, but very well set up. I was wondering if you had any examples of mislabeling that was not about a mistranslation. I think all of the ones you gave was a mistranslation. Like, yeah, so that's mistranslation.
Yeah.
Like, for example, maybe there could be cases where you translate correctly, but you're making a mention of something that culturally has a very different meaning in the non-English language versus in English. So the translation is correct, but in English it doesn't look hateful, and in the original language it's hateful. Does that exist?
Absolutely. So I think this case is pretty on point, like to what you said. Or like even like if you look at this one actually, it's a little bit similar to that. No.
Well, that's a pure mistranslation, no?
Yeah, it's mistranslation. Yeah. Yeah, so do you have...
Yeah, anyway, I was just curious about this because sometimes we translate correctly, but we still don't get the meaning anyways, but...
Yeah, so basically the way that we do our qualitative analysis is basically we have like the first 20 rows and we give them to some annotators, and then they just look at the one specifically where it's making a wrong prediction, and they're gonna look at the one where it's making like an explicit like wrong misunderstanding thing we talk about here. But maybe if we do more analysis, we might see a case that you just mentioned. Yeah.
I might add something. I'm the last author on the paper. The 4 languages that we studied have different The 4 languages in our data sets are from 4 countries where LGBTI people are accepted to different degrees. And therefore, in the Western context, people have reclaimed terms like homosexual. However, in Hindi or Tamil, these are still negative words, which corresponds to your scenario, where even if the translation is correct, the context of hate speech would be different.
Thanks. We have another question over there. Yes.
Thank you. Interesting talk. I was wondering, because some sentences are offensive and we are using large language models to detect the hates. Sometimes if the GPT has restrictions on the input, and I'm wondering if you set up the experiment with a large volume of data, will that kind of stop the running of the experiment?
Yeah.
And how would you deal with that?
Sure. So Faye, who was the lead author, did report that GPT would block her access from time to time. We had to do things like dropping that instance, masking the word, etc. And in fact, GPT does differently for different languages. So if you send the sentence with the word that starts with F that is used derogatorily for homosexual people, GPT blocks you by saying, don't say that, that's a bad word. But if you send the exact word in an Indian language, which is what I speak, GPT allows you to say that and says, yes, I know this is hateful. So in fact, the guardrails that we talk about are applied differently for different languages in the LGBT context.
So one last question over there, and then yeah.
I just got a interesting talk. I just got a question on like, what about like all of these examples are where hate speeches are really visible. What if when the terms are sarcastic or they're more like, oh, your pronoun is my lord, something like that. It's more sarcastic. Does it capture something like that, or what's your thought on future research?
That's a really hard question, honestly. I mean, if you look at the way that the data is labeled, right? It only has 2 labels, right? It's either like hate speech or it's not hate speech. I don't think we have a gray zone. It's going to be up to the data labeler, right? I mean, unless I make the data set and I provide some guideline or something like that, I don't think I'm going to have a say in like who, like the annotator, like how they're going to decide like what's considered offensive and not offensive. Yeah, I hope that answers your question.
Okay. Thanks, Duke. Same topic. So now we are moving to the next submission. The title is Comparison of Multilingual and Bilingual Models for Satirical News Detection of Arabic and English. And also is the team we Duke will present. So back-to-back presentation.
Hello, it's me again. So, okay. Just perfect. Okay. It's fine. It's probably fine. Yeah. Hi. So this project is so Omar was a visiting undergraduate student at University of New South Wales, and this is his 3-month project working on this, and I'm presenting it on his behalf. So this paper is titled "Comparison of Multilingual and Bilingual Models for Satirical News Detection of Arabic and English." So let's start by defining satire and unwrapping this. So satire is making fun. So like joining on from what Matthew has said previously. So yeah, we talk about satire. Satire is making fun of someone or something to embarrass or discredit them. So an example is, this is such a bad example. World's most honest politician promises. I would definitely let you down. So satire is context independent, and it's important because that makes it prone to being misclassified. Think of like in sentiment analysis or those sort of scenarios. So existing research in this area, satire detection has been around for a long time, uses all sorts of different stuff. It's been around since like the pre-deep learning era. And and it's moving on to like using language models and so on. There's two limitations with current satire detection research. Number one is that it's monolingual. And number two is that one of the most successful techniques, which is chain of thought prompting, is not really been studied in the context of satire detection. So identifying those two gaps, we want to answer these two research questions. So number one is we want to look at it from a multilingual context, and the first step could be comparing the performance of a bilingual model versus a multilingual model in detecting satire across languages on the same set of data sets. And the second one is doing those set of experiments with chain of thought reasoning to measure the impact of this technique on satire detection accuracy. So we utilize two models. Number one is Jay's chat, which is 13 billion parameters. This one is a bilingual Arabic-English model. And it's curated over Arabic and English prompt response pairs. The second one is Llama 2 chat, so it's 7 billions. It's like quite a bit smaller. And this one is multilingual, and it's also not explicitly trained on Arabic dataset, but we're going to see some interesting results with regards to this. So the two methods that we'll be using to compare them is first just using zero shot, just normal zero shot, and then chain of thought prompting. So most chain of thought prompting is like a one-stage process where you do analysis and then do the classification in one go. For this work, we first prompted to do chain of thought to generate like insights regarding satire, and then use the output to classify it in the second stage. So this is the general pipelines. We have English dataset, Arabic datasets, pass them through the two LLMs, and then for each one generate the zero shot and chain of thought predictions. Okay, all right. So we will also vary the language of prompting. So this is a bit of an update over like the previous work where we only use English for all the prompts. So hopefully we'll see some interesting stuff here. So because we have like English datasets and Arabic datasets, and we can try to experiment with using English prompt versus like Arabic prompts and see the effect of that. So this is the 4 datasets which we will be utilizing: a series, Sadani, Fusani, and Satirical LR. So the first two are Arabic datasets, the latter two are English datasets. So I'll just call them by the acronym ASI, and SRR. So all of these datasets are pretty balanced. Also, just one more thing I would like to add is I guess we haven't really assessed the difficulty of the satire in the dataset. So the result might not be comparable from dataset to dataset. Okay, so this is our results. So from left to right, we have the columns are D is for dataset, P is for the different training paradigms, and then we have the F1 score. So on the left block, we have the J's chat on the English prompts and the Arabic prompts. This is for the Arabic datasets. And on the right block, we have the Llama 2 chat on English prompts and Arabic prompts. So this is very interesting, and I would like to make a few observations here. So if you could first look at J's chat for both English prompts and Arabic prompts, and make the comparison between zero shot and chain of thought prompting, we can see that chain of thought prompting increases J's chat performance significantly, but there is a difference. So on the Arabic prompts, so we know that the zero-shot prompting, the F1 score for using the Arabic prompts is always better than the English prompts for zero-shot, which is very intuitive. So on the A data set, the zero-shot performance is 63.6, compare that to 59.2. And then the second row, it's 40.1 compared to 12.9. So that's very expected. However, when you apply chain of thought prompting, the English prompts get significantly better, up to 80%, whereas the Arabic prompts only get to 67.5%. So it seems like chain of thought prompting is much more effective for English prompts than for Arabic prompts. And the result is repeated on the SY dataset. So you can see on the for the English prompt J's chat, the improvement is around like 54% improvement. But for using Arabic prompts, the improvement is 19%. So huge difference. Okay, so now let's take a look at the right block, the Llama 2 chat. This is, again, very, very interesting. So just from a glance, we can tell that chain of thought prompting actually does not really improve Llama 2 chat performance. And we can also see that regardless of the prompt being used, it's like roughly the same performance. So there's two interesting things here, right? Number one is this is on the Arabic dataset, which is not really what Llama 2 chat is trained with, but it's already being able to make a non-random prediction. So that's really, really interesting. And yeah, and also just changing the prompt, I guess that doesn't really affect that. So now let's take a look at the English data sets. So on the English data set, let's look at the J's chat again. The J's chat, we can see that, again, chain of thought prompting improves the performance significantly. And we also observe that, again, it seems like with the English prompts, it improves the performance much more compared to Arabic prompts. Interestingly enough, if you look at the F1 score, the F1 score of the Arabic prompts is better than using via English prompts. So now let's look at the right block, Llama 2 chat. So again, we can tell that chain of thought prompting does not really change Llama 2 chat performance. That doesn't really affect it at all. And obviously the performance is better because it's trained on English data. And you can tell that if you compare between the right block, the Llama 2 chat on this Arabic dataset versus this dataset. So here's an example of how of side-by-side comparison between zero shot and before and after adding chain of thought prompting into the process. So if you look at the top articles, we have two articles here. The top one is the English one, and the bottom one is an Arabic one. And so we have the article above. The ground truth for it is satire. Using zero-shot predictions, J's chat predicts that it's serious, and Llama predicts that it's satire. This is the COT for J's chat. And yeah, so after producing this, the COT, J's chat is able to predict it correctly as satire. So yeah, so observations from our results. Number one, well, obviously, J's chat achieves highest F1 score with English prompts using COT prompting, and COT prompting seems to favor English prompts, and it seems to not work on Llama 2 at all. And another interesting fact is that Llama 2 chat model achieve exceptional recall scores across all data sets, exceeding 97%, which means that it gives a lot of positive predictions. So conclusion. So we can see that Llama 2 chat produces consistent outcomes regardless of prompting technique, and it's able to give good predictions on Arabic dataset even when it's not originally trained on Arabic training set. And COT in general is pretty good, and we still don't know why it doesn't work on Llama. I guess that's up for future work. And that's it.
Thanks, Duke. Very interesting. Okay, questions over there. Mike.
Thank you. I know that you're presenting this on someone else, but you might be able to answer generally, or even somebody else in the audience. How much of a dark arts is chain of thought prompting? Like, to what extent do you have to seed it with the type of insights that you're looking for it to find? Is there any sort of prior expert knowledge that you can bring to the chain of thought prompting, or is it a fairly standardized thing that people do? Thanks.
Sorry, could you please clarify your question?
Well, how much do you have to tune the chain of thought prompting in things like this? Like, is there a standard sort of prompt that you give it, or is there a lot of variation in the types of chain of thought prompting that you do that impacts how well it performs?
So basically, we have two sets of prompts. So basically, we have one prompt for the chain of thought prompting, and when we do zero shot, there's another prompt for the zero shot. For the chain of thought prompt, sorry, I have the text. It's a bit long, but basically, it's basically something like, oh, please, okay, you'll be provided with a news article, and you're required to predict whether the article is satirical or not. Your answer should be 1 if the article is satirical, or 0 if the article is serious. Do not provide any explanation or additional commentary. Do not answer with blank. So that was the first, and then apply another zero shot at the end to get the prediction. But we didn't do any variation to that prompt, so we wouldn't know what. Yeah.
Oh, yeah. Thank you very much. Thank you. Okay.
The quantitative result.
Deciding what prompt to use in this kind of situations. Because if you look at what you presented here, right, it's kind of the classic, you've got like a few variables, you've got the data set which you standardize as a form, and then you've got like experiments that you go with the zero shot, and you're account for, you're basically you're controlling the variables, and you're varying the experiments to all of them, and you compare them, and your F1 is like the experiment result. The problem I generally have in my own work is that when you get to the point where you're trying to adjust the prompt, all of a sudden you've got a gazillion ways you can phrase the prompt. And if you try to systematically tune the prompt, that just takes forever. And then we end up it's like sort of decision by exhaustion. You just get to one point and you say, okay, I'm not going to try to tune that anymore. And you just leave it, or you make your collaborator decide or something. Do you have any suggestions on what do you do when the variable is actually a string of like a prompt where the variable is like a string of text? How do you systematically tune it without taking forever in the process?
So I guess this is also in relation to the previous talk as well. It's kind of related. So basically, I mean, if you're trying to like doing prompt engineering and getting the highest accuracy possible, I wonder if we're really assessing the capability of the language model objectively that way. I think that probably the most objective way is to have like 3 people come up with 3 different prompts about the same thing and then average the performance of that, right? Because that's like, it's like natural language. There's like an infinite amount of variations. You can even add a space in between, or a dot, or like a full stop at the end of the sentence. And maybe that would have made a difference because, you know, the weights inside there, you know what they do. So I feel like if you do that, you're not really, if you're trying to like getting the highest accuracy possible, you're not really like trying to understand what the model is doing generically. You're just trying to, it's like a competition, something. I'm just thinking. Yeah. Yeah.
Okay, we have time for one last question. You want to ask?
I did some work with prompt engineering, and the way we did that is we mutated the prompt with several prompt engineering, including self-taught, expert prompting, and with the whole prompt engineering and genetic. So we run the algorithm for to generate different prompts.
Yeah. Yeah. Thank you for that. Thank you for answering.
Okay, thanks again for. So then we reached to the last presentation of today, and actually it's like the cherry on the top for a wonderful day. This next presentation was awarded the best paper. So the title is Generating Bilingual Example Sentences with Large Language Models as Lexicography Assistance. And I think the first author, Raphael, is going to present the work. So it's a long type submission. Thanks.
Hi, everyone. Last one for today. I'll try to not bore you. Maybe I can start with this talk with a confession. Usually, like in the middle of the afternoon, when my brain is a little fried, like now, I like to open my phone and open TikTok because it's a great way to rest your brain, is to watch a million short form videos. And I learn Indonesian, and TikTok knows that I learn Indonesian. And so it likes to show me videos in Indonesian. And so that's cool. Actually, I get to use it as a language learning exercise. It's like I get to justify myself for this bad habit. But to justify myself fully, I try to stop it and go to Google Translate when there is a word I don't know. So for example, this is a real example of a word I didn't know a few weeks ago, mapan, and I go on Google Translate. Mapan means established. Okay, I guess that tells me something about the sentence I'm reading there. I kind of understand it now. But at this stage, I'm definitely not confident enough about the meaning of mapan to myself use it in a new sentence. And so, because I'm still a bit lazy, I just go on ChatGPT and I go, what does mapan mean? And give me some example sentences of this word. I do this because it's easy, but I also do this because oftentimes I'll follow up with another question where I try to reuse that word in a sentence that I formulate myself and ask ChatGPT, okay, so can I use it in this way? And I think that's a useful exercise. You want to be active in how you're learning this word. But the problem is that I don't know if this is good, actually, because I don't have the Indonesian skills to know whether ChatGPT is giving me good example sentences. And so this is the core question of our paper. It's actually in lexicographic work. Generating example sentences is recognized as very useful for language learning, but also expensive, because instead of having this one word, you now have to generate full sentences for potentially thousands of entries. And if we want to determine whether it's good or bad quality, we have to look across different languages of different resource levels, across different LLMs. And if they're not of great quality, are there ways to make LLMs better at generating them? So we looked at related work, and actually we found papers that were all in high resource and monolingual. So for example, earlier this year, there is a paper from Satirical that found that ChatGPT gives example sentences in English that are preferred by humans to the example sentences inside of the Oxford English Dictionary. They actually set up an eval that is exactly that, the win rate against the Oxford English Dictionary, and then they get over 80% just using ChatGPT. But they only work with English. And then I think at ACL, there was Benedetti et al. They work with Japanese. And actually on Japanese, they find that human-generated example sentences are preferred by humans than the ones generated by GPT-4. But all of this work is monolingual, which I think, I mean, when you learn a language, usually if you want an example sentence in a language that is not yours, you also want it translated to a language that you understand better, right? So it makes sense to work in a bilingual format where you have a source and a target side sentence. And also all of this work is in high resource languages. So it bears the question, like, how does it work for like lower resource languages? So that's our research question. I mean, it's kind of a reformulation of what we put in the paper, but like how good are LLMs at generating example sentences in a bilingual context across languages? And so we set up an experiment. We work with 3 languages on the source side, French, Indonesian, Tetun. So Tetun is the most spoken language in Timor-Leste. And French is our represented high resource language. Indonesian, I think we could say like middle resourced. And Tetun is low resource. We work with GPT-4o because at the time we wrote this paper, it's the LLM that had the highest ranking on the LMC's leaderboard. And then with Llama 3.1, the largest version, over 400 billion parameters, because it's the open model that had the highest rank. And then we found a set of criteria that was set up by linguists called GDEX, which I'm going to present to you now. So they say that for an example sentence to be good, it needs to fulfill 3 criteria. It needs to be typical, informative, and intelligible. So typical, like I have some examples here. For example, the word successful, typically we use it for like people or organizations. A typical completion of a puzzle completely works. It's very valid, but if I wanted to teach the word successful to a person who is learning English, this is not the first example I would use. Informative, you need to add a little bit more information about that word compared to the word definition. So like they were successful, like it works, but it's not at all informative. And then intelligible, like of course you want the sentence to be really reasonably simple. And then we add 2 more. One, is the translation correct? Because we work in a bilingual setting, and we found in early experiments that LLMs could generate good example sentences in both the source and target, but they were not good translations of each other, which is confusing when you learn the language. And we also added an overall rating from 1 to 5. So we just we asked the annotators, what is your gut feeling about these sentences? Everything else, you can even ignore the GDEX criteria. 5 is very good and 1 is bad. And we set up like an annotation pipeline. So for each language, we sample around 50 words in the top 10,000 most used words. We translate them to English, and then we pass that through an LLM asking for sentence pairs. And then we rate them against the GDEX criteria. And for each one of the 3 languages that we have 2 annotators, both of them native speaker of the language. One annotator has either an NLP or a linguistic background, and one annotator is a layperson with no linguistic background. So this is an example. This is what we have in the paper. So like in Tetun, the word Rai means country. The LLM has generated a source sentence in Tetun, a target sentence in English, and then the annotator has given qualitative answers to the GDEX ratings. So either no or somewhat or yes. And they've also given an overall rating from 1 to 5. And so this is what we find. So the first finding is very expected, but it's good to set that baseline. We have the performance that degrades with the language resource level. So the quality of examples generated in French is actually really high. It's very rare that we give a no or even a somewhat. In Indonesian, it's medium. You can see that the performance starts to degrade, and then in Tetun, it starts to be pretty bad. When we looked at the results per large language model, we found that GPT-4o was statistically significantly better than Llama 3.1. But actually for Indonesian and Tetun, there was no statistical difference between the two. And that was quite interesting because if we had stopped at French, we could have said like, well, yeah, of course, GPT-4o is better than Llama 3.1. And so we can expect the same thing to be the case for Indonesian and Tetun, but actually not so much. Like even in Indonesian, I mean, it's not statistically significant, but it's actually a little bit better for Llama 3.1. Yes. But at this stage, this gives us a lot of trouble. We find relatively low rates of inter-annotator agreement, especially in French and in Indonesian, and actually reasonably high rates of agreement in Tetun. There's different ways to interpret this. One is, well, actually past literature on example sentences finds the same thing. It's a task where people disagree with each other. And when I asked linguists, they were like, oh yeah, like you'll find as many ratings of examples as you'll find linguists. Like we all disagree with each other about this. But I think something else that happened here is that the examples for Tetun, some of them were like clearly bad and some of them clearly okay. And you can see in the bars that I showed you earlier, there's just more noise. Like there's more information to capture. And so there's more likelihood that people will agree with each other. Versus the examples in French, like honestly, they're good. I was one of the annotators for this language, and so there's not a lot of information to capture, and as a consequence, the inter-annotator agreement is quite low. So okay, at this stage, to be fair with you, it's like our recovery from this trauma of the low inter-annotator agreement. Can we like at least align an LLM with the specific annotator's preferences? If I like a certain kind of examples, can the LLM align with me? And so we set up a little pipeline of in-context learning. We actually also use a chain of thought, but I'm not showing it here. So we have 100 annotated examples per annotator. We keep 10 examples at random for the prompt, and then we will eval on the rest of the 90 examples. And we ask the LLM to rate these 90 examples. And then we compare the LLM rating with the comparison. So we use the overall rating from 1 to 5 here. And what we find is that for every single annotator and for all languages, we can have some statistically significant alignment between the LLM and that annotator. And that surprised us actually, because these LLMs were, for example, not very good at generating Tetun example sentences. But it seems like they, at least the LLM that we use for rating, has some idea about what sentences could be good and what sentences are likely to be bad. Another experiment we set is that we work with pre-trained language models. So we work with, I think, Camembert in French, and then Indobird in Indonesian, and in Tetun we fine-tune XLMR on a Tetun monolingual dataset. And then we look at the correlation between several of the GDX criteria and LM metrics. So one that is quite intuitive is like the word probability, like the probability that this specific target word appeared in that sentence. Does this correlate with whether the sentence is informative? And then for intelligible and typical, we looked at the sentence perplexity. Like the intuition there is that, like a sentence that is convoluted will have very high perplexity and will also be not very intelligible. And for informativeness, we look at entropy at the place of the target word. And we find that perplexity in Indonesian and in French has a negative correlation with intelligibility and typicality. But we don't find anything for Tetun. I think for Tetun, there's just not enough data. And so like our fine-tuned model doesn't perform very well. For Indonesian and French, the results were interesting because this was intuitive about perplexity, but for word probability and informativeness, we had expected to have some statistically significant correlation there, but it wasn't the case. And it's very possible that the LLMs we use are just better at French or Indonesian than these pre-trained language models. And so if it doesn't make sense to put this word at that sentence spot, the LLM would not have done it anyways. And so there's not a lot of, again, there's not a lot of signal to capture. So conclusions, LLMs can generate pretty good bilingual example sentences. I've actually continued using ChatGPT to generate my little example sentences for Indonesian. Performance degrades with language resource level. And then we find it's coherent with previous literature that annotators don't agree with each other, but LLMs are creating a context where they can be helpful in this context. And future work, yeah, we would like to further our work on rating, where you could use an LLM to select the best example in a number of candidates, or you could use an LLM to self-improve if it finds that the rating is low. And I think if I had to start this paper over tomorrow, I would rethink the annotation design a little bit. That's it. Thank you.
Thanks, Raphael. Questions? Okay, we have some there at the back.
Yeah, it's a low correlate, low is the annotated correlation, also because you have a bias in your annotator. You say one is a lay person, one is a multi-person, ignoring the technical results now because you know if you do enough NLP, even sentences like colorless green dye obviously looks pretty. So you know how typical really kind of text. So have you considered potentially going to labels on two
Yeah, that's possible. So we looked at that a little bit, like whether we could look at conclusions depending on who the person was. For example, maybe the NLP researcher is a bit more strict than the layperson because they're used to, because they're more demanding about the quality of text. But it wasn't the case actually. Like, for example, I think in French, the NLP person was rating a little slightly higher, and in Indonesian, lower. It's very possible there is something there, but we couldn't really capture a signal along that dimension.
Okay, I think we have another question here. Yes.
Clarification question. You said that you were generating bilingual examples, but your results are only on the 3 languages. So how does the quality of the English side get embedded within these metrics that you showed?
Yeah, it's a good question, actually. And I think the way we're presenting it is not very clear. There is this one criteria about whether the translation is correct, is really where we capture like the quality of the relationship between the source and the target sentence. And also when we give these GDEX criteria, they're not only about the source side, like if a sentence is typical in French, but its English equivalent is not typical, they can discount for that. But because I always work with English on the target side, I'm only showing results saying, oh, this is French, Indonesian, Tetun.
Yes.
Thank you for the talk. It was super interesting. I had one first question was about the inter-annotator agreement. So I can understand that the inter-annotator agreement for those linguistic notion of the typicality, informativity was low. but it seemed to me that it was relatively low also for the correctness of the translation.
It was low for the correctness of the translation. Oh, wait. Yes. Yeah. I think what happened, like, for example, in French, right? So we are responding yes for like over 95% of cases. So imagine that I'm actually responding yes in 99 of my 100 annotated examples, and I'm saying somewhat for example number 52, and then annotator 2 for French is saying somewhat for example 58. You know, as soon as you have this line will show a very low inter-annotator agreement, and it's just because like there's not a lot of signal to capture, even along that dimension. I do think it mattered, but I also think people prefer different things and are more harsh or less harsh.
Just one comment. I was wondering if you plan to evaluate LLMs on polysemic words, see if they can generate good bilingual examples in a sense-specific way. Maybe that's the direction.
Yeah, you're right. Like, so when we translate the words, when a word has several definitions, we chose one it was manually done, and so we choose the translation that we feel is the most common translation. But there is interesting work to be done in this area around words that have several definitions. Actually, I mean, there's loads of interesting work to do in this area because it's very common to generate these example sentences, and there's not a lot of literature, and LLMs are promising. So yeah, but I'm not personally planning to go much further, actually.
Okay, right on time. Thanks, Raphael.